So rather than do labored introductions, I'm going to have each of my panelists do a quick introduction, tell you who they are, where they are from, and who they represent. Anil, I'll start with you.
Hi, good afternoon, everyone. Sean, thank you for the introduction of the session. At least we got a big hurdle to cross there. So, Anil Khurana, I'm based in Boston. Till recently, I led PwC's global industrial practice, so pretty large practice, and I was very busy. I told my colleagues here now that I decided in July I would actually take some time off and do things that I wanted to do. So I finished my last full-time job a couple of months ago, but I'm now on a couple of boards. So I'm on the board of a company in Zurich called O3 Smart, which is a digital manufacturing software platform. I'm on the board of a company in Saudi Arabia, and then in a sustainable aviation fuel platform here in the US, and I'm also participating in a think tank. I've been an engineer, business advisor, private equity person, and so I bring all of those experiences together, hopefully in our discussion shortly.
Great, thanks. John.
Yeah, good afternoon. My name is John Dyke. I'm the Chief Executive Officer of SESME, the Smart Manufacturing Institute. SESME is one of the 16 Manufacturing USA institutes created to invest in manufacturing through our specific lens, and obviously ours is smart manufacturing. I come from the manufacturing systems world. I work for both Rockwell Automation and GE Digital prior to coming here as the CEO 4 years ago. So in those, in the last 25 years of my career, I've been in those organizations building and bringing to market, implementing and sustaining manufacturing systems in the sort of nexus between production operations and the enterprise. I would echo what our host, our facilitator just commented about as sort of interoperability being a huge challenge for manufacturers. We'll talk more about that, I'm sure, but there's such a great opportunity for manufacturing, this entire manufacturing ecosystem to engage in a much more collaborative way to solve some of the major challenges to ultimately create a more competitive manufacturing environment, which is what we're all about. So it's a pleasure to be here today.
Great, thanks, John. Adam.
Hi, my name's Adam Lee. I'm a faculty member at the University of Pittsburgh, and I think I'm here wearing sort of two dual hats. As a faculty member in the Department of Computer Science, my research interests lie in the areas of data security and privacy. Over the last couple of years, I've worked with a number of collaborators looking at these issues in home and workplace IoT systems, and I think a natural extension is getting into sort of commercial scale IoT. I'm also my school's Associate Dean for Academic Programs, and with that hat, I bring an interest in workforce development and looking for ways that, the public sector and the private sector and academia can work together to prepare sort of the next generation of workers, of talent for these sorts of systems as we shift to more data-enabled economies. As we look at automating more, you're not necessarily going to eliminate jobs so much as change jobs, and we need to make sure that we're preparing folks to do that. So I'm really interested for the discussion today.
Yeah, well said. And Adam, we're going to rely on both of those hats. We're going to talk about security frequently, and it came up in the last panel. We're going to talk about workforce and upskilling. But first, I want to get a little bit of a base layer of what we're talking about today. I want to drive towards kind of what manufacturers can do to expand their IoT networks and operate, quote, as a service model. And to do that, John, I'm wondering if you can just kind of level set for us and define from a manufacturer's perspective what Internet of Things means in a factory setting, in an industrial setting.
Yeah, so the industrial Internet of Things, in a perhaps most simplistic sense, is the connectivity of manufacturing systems to some software environment, some digital environment that allows someone, a person or another system, to make better decisions about their operations. If I'm a large manufacturing corporation, I've been doing that for decades. If I'm a small mid-sized manufacturer, that's probably been out of the realm of what's possible for my organization. So if I look at the small mid-sized manufacturing landscape today, there is so much noise about this particular potential value creation. I'm overwhelmed by the number of organizations that are there selling me on this idea of digital transformation and industrial Internet of Things, and and smart manufacturing and the fourth industrial revolution. And it's difficult for me with my limited capital budgets to understand and discern who can I trust and where can I go to determine where my limited capital investment will be best spent. And then I do the homework and the research, and I figure out that there's this thing called pilot purgatory, and most projects in this space really struggle to scale and to become effective and result in what we would call a successful digital transformation project. So there's a tremendous amount of friction specifically for small, mid-sized manufacturers in this space that start with the noise and kind of move on from there. And so it's from our perspective at SESME, it's become really, really evident that we have to do a much better job as an ecosystem to decomplexize, to simplify, and to reduce the implementation cost for small, mid-sized manufacturers. And that requires building an entire ecosystem of knowledgeable and capable individuals whose business model actually works to engage small, mid-sized manufacturers. Because frankly, this entire digital transformation ecosystem is pointed at the Fortune 1000 marketplace and largely struggles to engage the small, medium manufacturers in general. So anyway, I think that's perhaps a bit of a baseline. It's become evident that small, mid-sized manufacturers are not within the mainstream sort of target market for this functional area, for this value creation, but they desperately need to be. So we have to be working on ways to more effectively educate and bring the small, mid-sized manufacturing ecosystem forward into this digital transformation area.
Yeah, it's so interesting, John. When you think about a region like Western Pennsylvania and Pittsburgh, we often talk, and Bill talked a lot yesterday about our industrial heritage that can often makes us overlook how many small and medium manufacturers are still in this region and make up a significant portion of the U.S.'s industrial capacity. And it's so interesting that we kind of have these automation conversations around them and focus on the big manufacturers. And your organization and your peers are so important in reconnecting back in to make sure we don't lose that manufacturing capacity. Anil, John's given us a level set at kind of the SME perspective, the individual company. Zoom us out a little bit from a market perspective. Is the U.S. competitive in adopting this kind of digital integration? What are we seeing across the Atlantic? You're on airplanes a bunch. Who's doing this well? Who's concerning you in terms of their adoption?
Well, thanks, John, for the comments, first of all. So one thing I'd say, while the small, medium enterprises, as John said, I think are struggling to actually make this work because of various topics, I don't think large companies have it figured out either. Right, so I actually start with that level-setting discussion. So to Sean, your questions. So I've been in the industrial field for the last 25, 30 years. In the last 10 years in particular, I think when the word digital first came out, I didn't know what it meant, right? I'll be honest, I didn't know what it meant. And this was 10, 11 years ago. And then I gradually figured out it was all ERP plus, that wasn't right either. And then I gradually figured out maybe 6, 7 years ago what it really meant. I was actually meeting a lot of my clients in the large companies, small companies segment. And in the last 5, 6 years is when companies have started to maybe begin to figure it out. And so 2, 3 themes to Sean, your question. One is that industrial companies are way behind consumer companies. So when I say that, we all are post-COVID used to the Amazon experience, whatever that may be for individually you. But as one of my friends said, I can track my pizza delivery from order to home, but I cannot track a part on the shop floor unless I jump through some hoops, right? So that's a bit of a comparison that would make. Now, I'd throw out another fact, which is actually more numbers. In the next 5 years, they estimate, and this is the Gartner and the Forrester's estimate, that the B2C segment is going to spend something like $4 trillion in the next 4 or 5 years. The B2B segment, and this is partly a result of COVID and all, is going to spend 3 times that, so $12 trillion. And why is that? I think the reason is that in the last 10 years, industrial companies were looking at short-term pressures from the market, for SMEs, how do I pay my salaries and things like that. So investments, if I look at the trade-off between cost reduction, so profitability, innovation, and other things, innovation took a backseat for industrial companies by and large. And the reality is that it's caught up with us. And when I say it's caught up with us, I visit US factories pretty regularly. I visit German factories pretty regularly. I visit factories in India pretty regularly, Japan. And in the last, I spent about 10 years in Dubai as well. So I visited a lot of Saudi factories and all. What I find is, and there are studies on this too that will repeat the same thing I'm going to summarize, which is that all of them are way behind where they should be, could have been compared to, let's say, the semiconductor or consumer companies. But having said that, German companies, I think, are still in general, and I think there's some international companies here as well, a little bit ahead of US companies. And I think some of the drivers for that are a bit of the German model of the Mittelstand businesses, which are mid-size, a couple $1 billion in size, who are the innovation engine of Germany. And if I look at some of the metrics that have come from those German companies from digital transformations and in particular IIoT and Industry 4.0 solutions, software and all, have been able to show bottom line improvements of 10, 20%, which is a big number, right? You squeeze out 1 or 2%, that's great. 10, 20%, that's like massive. And I've done a few case studies that actually show that as well. I think on a similar comparison in the US, the numbers have been smaller, and I think there are 2 or 3 reasons for that. One is, I think as I mentioned earlier, investments have been behind. And I think the US tax structures and all haven't quite caught up with, I think, what the Germans are doing. The second factor, and I was talking to these gentlemen earlier, is the labor unions don't trust executives and investments. Because for them it could mean, and I think you heard this in the last day and a half as well, that could mean jobs are automated, the jobs are gone. But at the same time, the incentive to learn something different and new, we haven't quite been able to inculcate that as well. So let me pause there. We'll come back to some of these topics later on too.
Yeah, mind if I pile on?
Yep, no, go ahead.
So if you go to the Federal Reserve, I think it's called the FRED, and download publicly available numbers on manufacturing productivity by worker here in the US. I think the early 80s is kind of when they began tracking these numbers, but you look at that productivity curve, right up until 2011, which ironically is when the fourth industrial revolution was first kind of publicized as a thing. Our productivity growth was steady and significant. The fourth industrial revolution was kind of brought up in 2011, and roughly $10 trillion of value creation was slated to happen here in the US, 3.8 trillion of which was going to be in manufacturing operations. So one would anticipate that productivity curve would at least remain on the trajectory it was on, if not increase or improve. But for the first time in recorded history, in 2011, that productivity curve flattened and then began declining. So there are obviously some nuanced reasons behind that, including a lot of geopolitics, socioeconomic dynamics, but I think there's a huge impact on manufacturing operations in terms of the maturity of our existing investments and the fact that we've squeezed every drop of productivity out of many of the existing methodologies and approaches to continuous improvement, automation systems, and manufacturing technology. And so I think what we're talking about here is vital if we're going to regain our position here in the US. Again, I think I agree 100% with Anil that we're behind Europe in terms of the adoption of smart manufacturing and Industry 4.0. And arguably, Europe might be behind Asia in many situations. But the point is, for us here in the US, we have to accelerate the adoption of these capabilities, both on the knowledge, the transformation, people, process, and the technology side. So this is not, from our perspective at the Smart Manufacturing Institute, this is not an academic exercise. We are absolutely feeling the sense of urgency around helping not just the large organizations, but the small and mid-sized manufacturers accelerate their adoption in this space.
So Adam, I was going to ask you a security question, but we keep pulling towards this human element, this productivity element. So let me ask you some workforce outlook on this instead first, and then we'll come back to some of the security considerations. what are you all seeing in your research and in your engagement with industry, kind of what the need is to power these 4IR systems on the industrial side, and how are the academic systems, Pitt in particular, responding to that opportunity?
This is a great question. Excuse me. I worked with some colleagues from our School of Engineering a couple years back to talk to some regional startups and companies in the IoT space and look at, what are they looking for in employees and what are you looking for in terms of academic preparation? Where are things falling short? Where are things good? And across the board, some of the feedback we were getting was that, all right, on the technologist side, people come out with, an electrical engineering major, a computer science major, and they're technically strong in their area, but they're not necessarily talking across areas in a way that's necessary to really understand sort of the social implications of data collection, the business case for automating or innovating, and looking at ways that, we can try to facilitate those conversations across disciplines. And there are examples of this. So there's the Mascaro Center for Sustainable Engineering at our School of Engineering brings together folks from across campus to look at sustainability as a concept, as it impacts engineers, as it impacts business. Our Innovation Institute is looking to bring together, teams of students and faculty from across disciplines, business, the sciences, computing, to have those conversations, to work on those, multidisciplinary skills and that ability to talk across boundaries in that respect. I think the other thing that we're seeing is that, as business becomes increasingly data-driven, increasingly data-oriented, folks might have been in a job and, you're an organization that has thousands of spreadsheets worth of data, but not necessarily integrated data across all of these systems. And how do you take the folks that grew up with that view of the data and scale their skills to reskill them or upskill them to deal with huge amounts of data, integrating data, messy data, and all of the associated issues that come with that. And here, we were talking prior to this about a need for mid-career reskilling or upskilling. So smaller credentials, smaller engagements where folks can come in and develop new skills. And within our school, we've launched an applied data-driven methods graduate certificate that's meant to bring sort of these core data science competencies to folks without that background, so that they can come in. And so our team has gone out and gotten funding from a variety of federal sources to invest locally in scholarships for folks to come in and pursue that in hopes of trying to build some of that workforce to do that. On the other side, though, you've got now, let's talk about on the shop floor. If we now have, technology that's deployed there, are we looking at mid-career reskilling, or is this sort of a new need for baseline competency in technology and maintaining potentially fragile sensor systems and things like this? And so I think there's a real opportunity in, 2-year degrees and working with, community colleges and sort of regional schools like this, trade schools, to, I think this is a revolution that's ongoing. Has to be a conversation between educators and the industry to figure out what's needed and sort of build those talent pipelines there.
Yeah.
Can I add?
Oh, yeah, go ahead, Anu.
So a couple of months ago, I was actually speaking with the CEO of a large Japanese tier 1 automotive supplier. So they have a US operation, which is about $10 billion. The Japanese headquarters is about $40 billion. And they're both faced the same situation. They've got to retrain their labor force, except the Japanese and US cultures and education systems are very different. So in Japan, the model was, we've got to take these 10,000 people. We will, as the company, train them, pay for them, go to a university, design a program. When I say university, I mean any educational program, vocational training and so on. Design a program and in 2 years, get them over the hump. I think the US, the answer was same company, but US setting. We actually give them annual opportunity to go train themselves. We give them some funding to go train themselves. It's up to them, right? So in the US, the model, which I think is a very fair model, you take care of your own career. You train yourself, and the change that's happening though around us is so significant that may not be enough, right? So let me just pause there.
Yeah, and the real opportunity, and then we'll get back to the tech because I'm going to get in trouble for getting us this off track. But I think it's important because the tech industry is not creating the jobs, at least not in here in Pittsburgh, at all levels of socioeconomic impact, of all levels of educational attainment, the way that I think in the early 2000s we imagined it would. And this intersection of the industrial space of advanced manufacturing with tech, and especially with robotics, potentially is that missing element, that magic bullet that we've been looking for that creates broader access. We're going to grow this robotic space, but we're going to do it in a way that also creates jobs for people who don't have PhDs from the Robotics Institute at CMU. So I think as GMIS America continues to grow, this is a conversation that's going to be really critical to the union between the robotics, AI, and manufacturing spaces. So with that, let me jump back into the tech. Dr. Herbert was talking with Brian Selesky about the big sexy thing that Pittsburgh does, which is industrial robots. I had a chance to see the robotics automation trade show in Detroit a couple of weeks ago, and it's really a giant exposition of what robotic arms can lift more stuff. But as I've learned from you all in the past couple of hours and days, fourth industrial revolution as it comes into contact with manufacturing isn't just the things, it's the data systems within the things. So John, starting with you and then Anil and jump in, like what are we actually talking about when we look at the opportunity on the factory floor? What are the things that are holding us back from really unlocking some of this digital transformation potential?
Yeah, I think that's one of the most important questions that we ought to be pondering and kind of working through and investing in. The last 40 years of Industry 3.0, and I would argue that despite 10 years of talking about Industry 4.0, this ecosystem has largely been, if I can be a little bit crass or provocative, has been putting lipstick on the Industry 3.0 pig and calling it Industry 4.0. And frankly, that's sort of partly out of necessity because the challenges that we've created for ourselves over the last 4 decades of Industry 3.0 have created a tremendous technical debt and a tremendous sort of flywheel or impetus in how we implement systems and how we build machines and how we develop software. And unlike other businesses or call it B2C environments, technology can't just show up on a shop floor. There are machine builders, there are systems integrators that have to be trained and have a business model that they will sustain. There's obviously academia at the front end of that talent pipeline. There's the technology providers, the vendors, and then there's kind of the OT vendors like the Rockwells, the Siemens, the GEs, and there's the IT vendors like the SAPs and the Microsofts and the consulting ecosystems around them. There's a tremendous inertia when it comes to manufacturing who does not adopt technology quickly or easily to bring that entire ecosystem forward. So turning that battleship or that ocean liner on a dime will never happen, which means that we have to work collectively to solve these challenges, to bring the baseline of knowledge up the 2 or 3 notches that are required, to bring the best of OT and IT together in ways that actually solve problems for both parties, not polarize them. I think we all know that the OT-IT convergence thing has been much, much more challenging than most people anticipated. We still haven't solved it after 20 years of working on it. I think if I can summarize all of that by saying we have to behave in ways that are more collaborative, more opportunities to partner to solve these significant challenges, not proliferate the proprietary behaviors and technologies and standards that have brought us to this point.
Yes, we were talking before that this sounds very much like the Mac PC battle of the 80s and 90s. Are you doing a walled garden? Is it your IP? Anil, how do we push past these data silos? Who's doing it well? Whose job is it? Are we even pushing past data silos to really get past the third and a half industrial revolution?
Yeah, let me start by first actually building on John's comments, saying when we say Industry 4.0, 4IR, digitization, what do we actually mean? And I know the audience is quite broad, so I'm actually going to make it simple. So we connect some devices. whatever those are, your phones, your machines, your cranes, and so on. So, and long ago, Industry 3.0, these devices were connected by mechanical things. Now they're connected by Wi-Fi data networks, essentially. You connect them. Next thing is go to pull data. I think that's what Adam said. It's all about data. Professor Herbe said the same thing. It's all about data. Data alone is not enough, right? Now you've got to figure out what the analysis is, what the insights are, and that's where the new skills come in. You take these volumes of data, you analyze them, you make sense of them, and then you decide whether you want to automate that decision making or you keep the decision making with the human being. So that's, I think, the fundamental logic of this business of 4IR. But this business needs to sit in an organization, in a factory, in a company, and that means there are systems there. So this all happens within the context of the system. It's not one machine to another machine, it's actually the whole production line, the whole factory, the end-to-end supply chain, right? That's got to be hooked up in the system as well. Driving all of this, of course, is people, right? So people need to be the right skills, analysis skills, and so on and so forth. So that's, I think, the building blocks of how we get there. Now, to your question, Sean, and it's in a way, it's actually even pre-Mac and pre-PC. Remember Microsoft DOS? Right, DOS was the platform on which Windows was built. And it's like a house of cards. It crashes. Remember? We used to joke, if cars crash the same way software did, they'd never run, right? Not the other way around. So software's come a long way since then. But the notion of the complexity of these technology stacks is the key one that I think John alluded to as well in Sean's question. So today, if I think about that, and I'll try to simplify, and we had a bit of a discussion earlier, you have the traditional machines, some of them 50 years old, some of them 5 seconds old. Some are connected, some are not connected. You've got to connect them up. Common standards, common requirements there. Once you do that, then it's actually a new play. It's not the old play. And when I say that again, it's not SAP can actually suddenly connect some dots and say, yeah, we'll make the ERP work on a manufacturing shop floor. They can't. MES, which have been around for a long time, and by the way, I spoke to several dozen shop floor workers and supervisors saying, do you use the MES in its full functionality? The answer is no. They use like 20%. Rest is spreadsheets, because the MES was not designed to be used by shop floor workers. Actually, was not designed to be. Architecture is right, but the usage patterns were not. So if I cut through all of that and say, think of the future design of a software system that runs 4IR in a factory, in a supply chain, got connected machines, devices, whatever those connected things are. That's the easy part in a way, even though it's not trivial. Then all the data that comes through, and the data comes in silos. When I say it comes in silos, some come from machines, some come from suppliers, some come from workers. All the data comes together, and you've got to figure out a way to actually cut through all the data and analyze it. This does not need the traditional stack of an MES and a SCADA and an ERP and a dashboard. It actually needs a different architecture. And that's the transition between the current architecture and the future architecture, and this is clearly not going to happen overnight. And we all agree that God made Earth in 7 days, but actually changing the current Earth will take 7,000 years, right? So greenfield easy, brownfield very, very hard. If we have to build a new machine, new factory today, much easier than actually converting the existing ones to the future.
So from a non-technical background, it sounds like what we need is Alexa for advanced manufacturing. And John, that's actually something you all are working on, which I think most would be surprised that that's in your business line.
Yeah, so as a federally funded manufacturing institute, one of our mandates is to reduce the cost and complexity and the time to implement smart manufacturing systems by 50%. Which is an audacious goal. And so when I got here 4 years ago, the Institute was brand new. We spent a lot of time pondering this question about what can we do that allows us to engage with every group of stakeholders in this ecosystem, which includes the manufacturers, but as I mentioned before, it includes the technology providers, the machine builders, the systems integrators and consultants, and academia. If we're going to solve a problem in a way that truly transforms the industry and disrupts the industry and helps build that productivity curve back up here in the US, we're going to have to do so in a way that improves the business model for every one of those stakeholder sets. And so we went back to the very fundamentals of as Anil just pointed out, data contextualization, and exposing data to the applications that can create value from that. And we came back with the idea that we need a publicly available, mission-critical contemporary, Industry 4.0 centric data ingestion and contextualization platform that we can essentially give back to the industry so that the innovation, the applications, the crowdsourcing, the open sourcing, the entire technology provider community can invest in that infrastructure in a way that allows it to become democratized. And that's the idea of democratization, is simply about a business model that says we're going to make it simple and low cost for the masses to adopt. It's the Microsoft SQL versus the Oracle approach. Democratizing on the SQL side, Oracle just as viable and compelling a business model, but it's not democratized. So the whole idea is to build this data ingestion and contextualization platform, and all of the tools, a marketplace, information model designers, and the actual platform itself, make them available in a low cost, low friction way in a cloud-based environment, so that anybody literally in a few seconds can engage with them and begin innovating within seconds versus months or weeks or months.
So Adam, as John is working to reduce that friction, especially for small and medium manufacturers, if I'm putting myself in their shoes, a lot of the words that have been said on this stage in the last 30 minutes are really intimidating and concerning to me. Open data, data exposure, data integration, open source, all of that in the age we're living in, where industrial sabotage is a real concern. What are the security considerations that are underway? How can you reassure me as a business owner? And where are the gaps that researchers and academia are driving forward with industry to close?
Yeah, so what's interesting, and what Anil and John have been saying is, like, look, we've got machines that are 50 years old. Ostensibly, this is data we've been collecting, right? So it's not necessarily that it's new data, but it's seen in a new context, right? So the nice thing about a stovepipe is that it's a stovepipe. Whatever happens in there stays in there. It is the Vegas of manufacturing. When you want to, look at connecting these things more broadly, obviously now you got to start thinking a little bit more about, okay, how are we handling this data when it's coming out on these broader, shared connections, and what's going on there? I think one of the things that came up in the last panel that I think is interesting is that this data is not just about the environment or the machine. It's about, the people operating it, about the culture in which it operates. And how we look at this, right? This data that might be telling me the efficiency at which a machine is running. Am I using that to infer things about my workforce, for instance, that otherwise I wasn't looking at before? So I think there's a lot of data governance and implications or ethical questions around how we use that data, right? So that's another piece. But I think the one that's sort of the scariest to me is looking at how connectedness is going to impact availability. So if we can get things talking to each other, I think there's a tendency to use that to optimize. There's a tendency to do real time and all this sort of stuff. And now what happens if a cloud provider goes down, or there's a storm, and an otherwise plant that could run on its own loses its connection to the mothership? What happens then? So again, if you've got some older machines running in stovepipes, they can continue to operate if something else fails, unless you've got a dependency. But now if if I can't report data that I need to report, or I don't have the data I need to make decisions, what happens now? So how do you fail safe? How do you ensure reliable operation, and that you don't, over-optimize yourself to a point where a communication failure or breakdown can just grind everything to a halt?
That's really interesting. I'm thinking of it from a consumer fashion as always, and it really comes back to how much the B2C sector has pushed this. But get on an airplane when you have all your movies downloaded, but that Wi-Fi connection isn't there, and everything short circuits. And what I've learned over the past 2 days here at GMIS is everything in the industrial space is so much bigger than I think we as consumers can even realize, to try and magnify that at a multiple plant base and a supply chain base. You lose one cog, you really start losing the whole system. I want to go back a little bit to how we drive this forward, especially here in the States. John, as you were saying, a lot of this is happening at a prototype and then adopt basis. Marcel and Brian were alluding to the Build Back Better application, an award here in Pittsburgh. Catalyst Connection is going to be channeling a lot of those dollars and the academic expertise at Pitt into SMEs. But how do we make sure that, and are you concerned about that those pilots actually get built out at scale? We don't just continue piloting things to death.
Yeah, another great question. One of the great sort of challenges and opportunities with federal funding is to drive and utilize that funding in a way that maximizes the outcome. In other words, when you use federal funds to solve a problem and create an innovation and do something really important, you can do so in a way that helps that manufacturer, or you can spend a little more time and be a little more thoughtful and perhaps engage with the broader community and solve that problem in a way that allows 1,000 other manufacturers to benefit from that innovation. And so that's the piece that we're trying to urgently trying to advocate in the marketplace right now, with a lot of federal funding making itself available, specifically a great focus on small and mid-sized manufacturers. But if we're not careful, we're going to, in each state, kind of build these fantastic lighthouses that inspire other manufacturers of what the art of the possible is, and look at that beautiful digital transformation, and they improve their productivity by 15%, and that's just awesome. But the $250,000 it costs that small manufacturer to implement that awesome lighthouse will cost the next manufacturer $250,000. But if we could do that first project that costs $250,000 in a way that literally 1,000 other manufacturers could implement for $50,000, and then $40,000, and then $30,000, all of a sudden you're democratizing the entire approach. You're building templates, repeatable components that are translatable into other industries and into other technology stacks. You're not building silos. You're creating interoperability in the process. And so that, to me, is an urgent opportunity for those of us here in the U.S. right now to ensure that we're not just building lighthouses. We're building lighthouses in a way that's repeatable, translatable, not proprietary, so that we can drive down the cost. And there are 250,000 small and mid-sized manufacturing companies in this space. Helping 1,000 with these federal funds is a good, noble goal, but can't be the end goal. We have to be able to help all 250,000 of them.
Yeah. And yeah, Anil,
So I'll pick up on John's comment regarding scale across companies, but also go back to scale within a company, which is not a trivial thing either. So when I say that, you do a pilot, and by the way, when you say pilot, if you think about manufacturing and use cases or examples on how 4IR helps, it's like 1,000 of use cases. Quality inspection, machine maintenance, predictive, all those things are use cases. There are 1,000 of them. I don't even know how many there are. There are hundreds of them, if not thousands of them. Yeah. So when you pilot something, you actually pilot a use case, not 1,000 use cases. So one is going from one use case to multiple factories in the same business, then going to other use cases. That's, I think, one theme, which now suddenly a single company has to say, I spent $100,000 in this one pilot. Now I need to do this 100 times over. So that's a financial mindset hurdle that comes in. So that's one. Second, I think, as I mentioned earlier in one of my suggestions regarding how 4IR or this all works, it actually sits in a system. So systems around this, connect, analyze, action sort of chain have to come together in the system as well. And that's not trivial either. And third thing, which I think will be shocking to all of us is, and I mentioned this briefly earlier, the typical production worker on the shop floor is not incentivized to adopt technology and use it to its fullest. So when I say scale, yeah, we build a pilot example or a lighthouse line, and just like the Hawthorne effect, which was not far from here, all the attention is on that particular one. It succeeds because all the attention on it. Now to scale it up, you need every production worker on the shop floor to be familiar, tools, awareness, but also incentive. And that's not there either. So scaling is not a trivial thing, even within a company, and then scaling across. So both of those challenges, not insurmountable, but have to have, a mix of system, people, process elements behind them that can actually make them happen.
And Adam, that really goes back into your, we're asking about security, but really a lot of your consideration is about ethics, about the impact on the worker themselves. And I'm just curious your thoughts as we really stress the system with this pilot and scaling trajectory. How should we be thinking about the ethical implications of the workers themselves and not just thinking of them as another cog in the machine?
Right. So, I mean, this is a really, really broad question that goes, beyond my expertise. But I mean, some of this, I think, is what are the career pathways for existing workers, right? So you don't necessarily, if a worker doesn't have an incentive to adopt technology and use it to its fullest, it's because you don't want to be replaced by it, right? So, all right. So not only is how am I going to use this stuff to, help the company do better, help, the team do better, it's how's this going to help me do better? How's this going to influence my trajectory within the organization or across organizations? How's it going to open up new doors for me? So, I mean, that's a question that I would, I would want to see folks engaging with. And I'm doing some work with colleagues on campus with sensing, and everything we're trying to collect, it's, well, if there's one stakeholder collecting data, who else is it of use to? And can we look at, broader goals around access to the data to sort of make the environment as a whole better? And so I think when we do this, the bottom line is important, but the overall health of the organization includes the people in it. And so how can we ensure that as we're training people to, adopt new technologies, we're sort of giving them that holistic view of how it's going to empower them, empower the organization.
Yeah, it makes me think back to the mistakes that were made in Pittsburgh in the first and second industrial revolutions and making sure, and I think actually Pittsburgh is uniquely guarded against replicating some of the exploitation and the ethical implications of the fourth industrial revolution as well. So I appreciate your continued work there and that at the university.
Can I add a comment
Yes,
here?
go ahead.
So in the additive manufacturing session, a couple of sessions ago, one of the panelists made a comment saying, additive manufacturing suddenly attractive to my 25-year-old engineering son or daughter, right? That's actually pretty key, because what it means is the first, second revolution of manufacturing was dirty, blue, grease under his thumbnails, blue collar, absolutely, right? This next opportunity is for us to actually make it more technology-oriented, more attractive. And I think as Badar, who's one of the co-founders of GMIS many years ago, said, the goal is to make manufacturing aspirational again. Right? That's a key theme in how we train our next generation of engineers, production workers, vocational training colleges and all, is to not downplay, because look, in the whole world, industrial activities still are about half the reason for the GDP. Yes, e-commerce is interesting, sexy, all that, but you've got to make stuff to sell it, right? So this is still half the world's GDP. And to make that attractive, make that interesting to our next generation is important, because in some ways that's the skills that are needed. Is for a person, I have two girls, one is an engineer, one's a doctor, and the engineer would love to go on a shop floor and work in things like this, and that's what we want to make it interesting for most of our next generation students as well.
Yeah, and that gets to, John, your mantra of democratization in this space, increasing access and making sure, again, especially in post-industrial regions like Western Pennsylvania, that everyone has access to these new economic opportunities.
Yeah, that's exactly right. I think most folks today have one of these, and the skills we've developed over the last decade to actually navigate our way through and search and find information is not a skill set that was there when I was young and in college, kind of looking at my career opportunities. But most workers on the shop floor have to put this away in their locker. They can't walk on the shop floor with this thing because it's not safe, perhaps. It's not allowed. It's an IT security risk. But the whole notion that that generation of workers could, with their existing skill sets and the right approach from a top-down perspective around simplifying systems, simplifying data access, securely enabling that citizen technologist with the skills that they have today to solve problems. To me, that's what's inspiring about the space that I'm in, smart manufacturing. It's about the citizen technologist in a small shop with 35 people having the skills, if we can put the right tools in their hands, having the skills to engage in problem solving, not just making sure that machine has inventory next to it.
And what's so interesting about that is, we think about the impact of that locally in terms of democratizing access to innovation around manufacturing. At a global scale, when we think about the global south, we think about industrializing countries, there's an opportunity that entrepreneurs in those countries are going to leapfrog US and European-based systems because they are not working through these really big 250-year-old industrial systems.
That's what keeps me optimistic, that small, mid-sized manufacturers can, to your point, leapfrog the Fortune 1000 manufacturers who have this technical debt and this legacy installed base of manufacturing systems. So if we can drive this democratization piece forward, we represent a huge opportunity for that marketplace.
So we have just a couple over 5 minutes left, and so what I'd like each of you to do is leave the audience with a takeaway designed for the SME space. Imagine that I and those of us in the audience are small titanium manufacturer here in suburban Pittsburgh. What's the most important thing that we can take away from a session like this that's going to keep us competitive in an integrated digital industrial age? Anyone want to go first?
So let me start with that. So large companies and small companies have different sets of issues. Large companies can afford a couple of years of low ROI. Small companies cannot. Right? Again, maybe I'm being too demanding or expecting too much, but I think a small company doesn't want to actually run the risk of a 5-year, 6-year ROI on investment. So ROI investment's got to be short. What that means is, back to my use case example, take a use case, optimize it, scale it up, and then worry about the next 10 use cases. And all of that needs a few other things as well. You need the right software, the right people, but that would be my suggestion, is take a couple of baby steps, make them deliver, and then move to the next one.
Great. John?
So in my 34-year career, I've worked for 3 companies before SESME, GE, Rockwell, and a small software startup that focused on manufacturing intelligence. In my 34-year career, I've never once proactively sold anything to a small, medium manufacturer. Every part of this ecosystem is aimed at the Fortune 1000 because they have multiple sites, because my cost of sales in selling and implementing and driving value for one plant is all based on the notion that if I sell it to one plant, 5, 10, 100, 500 plants could potentially deploy it. We have to focus on an ecosystem for small, mid-sized manufacturers, which is what democratization is all about. But from where I stand, that's never going to happen with the traditional OT and IT engineering and talent development and technology stack approach. I love what Adam said a few minutes ago about smaller, bite-sized chunks of education that the average worker on a shop floor can have access to inspire them in terms of how to solve problems on the shop floor. Right? It's accessible to everybody if they have the willingness to be there, to engage, to do more than just operate that piece of equipment. How can we inspire them to be part of the problem identification and resolution process? And so that combination, it gets back to the basic people, process, and technologies, but doing so in a way that's thoughtful, that kind of breaks the mold of the traditional talent pipeline and education pipeline and technology development pipeline. I think that's the sort of paradigm we have to step away from and collaborate together as an ecosystem to work towards.
From an economic developer's perspective, especially thinking in Pittsburgh, that's how cities like Pittsburgh can be competitive with our big coastal tech hubs as well. There are way more customers at that small and medium manufacturing side. Their procurement systems are much easier to get through, and so your first customer time horizons get much smaller and arguably more productive. So it's really important takeaway. Adam, close us out from a workforce security or other perspective. What do we need to be walking away?
So I've liked this theme that we keep coming back to about being the need to collaborate, to get out of stovepipes, to work together, to build data models that other people can use, to develop training that lots of people can benefit from. to look at, talent pipelines moving from small manufacturer to small manufacturer, not necessarily being a bad thing. It's, distributing ideas. And so I think looking at ways to incentivize those sorts of collaborations are, the ways to grow this, right? I'm an academic, right? If I can see further, it's because I've stood on the shoulders of giants, right? This idea that we learn from those that came before us, we share information, other people can grow. So trying to build these, mid-size and small economies that way, I think, is whatever we can do to deliver that education, deliver the data models, deliver the processes, the things that, look, my company's not going to do what your company's doing, but if I can learn from how you're operating, then I can benefit as well. And it's not direct competition. It's, I do something new eventually that you'll take back, right? Yeah. So that's the thing. That's the theme that came out of this. I think that most resonated with me.
And that's the value of conversations and platforms like this today at GMIS. So really appreciate Simon and all of our hosts here today for creating the platform for that collaboration. Speaking of Internet of Things, I've been told by my Apple Watch that I've been sitting for too long. And so I'm going to pull us to a close so that I can stretch my legs. Anil and John and Adam, thank you so much for the conversation and looking forward to carrying it forward.
Thank you.
Thank you.